wabarakatuh. Good morning, ladies and gentlemen. First of all, I would like to express my thanks to the organizer of International Conference on Operational Research 2020 for the opportunity. My name is Ivah Edina. I'm a postgraduate student at 10 November Institute of Technology, Surabaya, Indonesia. Today, I would like to present my research, estimation of baseline hazard function on Cox model using maximum penalized likelihood with case study brain cancer at Lab Edward Tangerang. Here is the presentation agenda. First, I would like to tell you introductions. Second are methods. The third are result and discussions. The fourth are conclusion, and the last are reference. Introduction. Survival analysis is a statistical method where the variable to be considered is the time until the event. The method that can be used in survival analysis is Cox regression. In Cox proportional hazard regression, the variable should fulfill the proportional hazard assumption. But if there is a variable that doesn't fulfill the proportional hazard assumption, the methods that can be used are first, stratified Cox regression that used by making the variable that doesn't fulfill the pH assumption to be a stratum, and the second is extended Cox regression, variable that doesn't fulfill the pH assumption in extended Cox regression analysis has interacted with a time function such as length. In Cox regression, the baseline hazard function is unknown. With a baseline hazard function, there will be important components missing and the result cannot be used to report the whole model. The method that can be used to estimate the baseline hazard functions are Bayes' law, maximum likelihood, ordinary least square, partial likelihood, and maximum penalized likelihood. We note that the maximum likelihood and ordinary square used in a parametric estimation, and maximum penalized likelihood has smaller bias than partial likelihood. So in this research, we use maximum penalized likelihood to estimate baseline hazard and apply it to brain cancer patients. The next is methods. Cox regression. In survival analysis, we can see the survival time with independent variable which are considered to influence survival time by using estimation with regression modeling. The regression model in survival analysis, which is often used, is a Cox regression, where the relationship between dependent variable and dependent variable has exponential hazard function at a certain time. Here is the Cox model. If beta g is equal to 0, the hazard function will be equal to the baseline hazard function. In Cox regression, the baseline hazard function is unknown, but we can estimate the baseline hazard function using several methods. One of the methods is maximum penalized likelihood. In this research, maximum penalized likelihood is used to obtain the estimate beta and theta with Newton multiplicative iterative iteration. Here is the maximum log likelihood function. To make the estimate of theta have a positive value, we have to manipulate the baseline hazard function like this, so we get the new penalized log likelihood function. And we also know that the j theta is a penalized function. To estimate the beta with Newton-Rapson iterative, we need this step. First, we have to determine the first derivative of a penalized log likelihood function. The second, we have to determine the second derivative of a penalized log likelihood function. And we have to input them into a Newton-Rapson formula. The iteration will be stopped when the beta with k iteration minus beta with k plus 1 iteration have a value less than the epsilon. To estimate the theta with multiplicative iterative iteration, we need this step. First, we have to know the first derivative of the new penalized log likelihood function. The k of multiplicative iteration is solving penalized function to be positive function and negative function like this. According to the Karush-Kantaker equation, we note that the first derivative of the new penalized log likelihood function obtained to theta will equal to 0 if the theta have a value more than 0, and the first derivative of the new penalized log likelihood function obtained theta will be less than 0 if the theta is equal to 0. But in this research, the first derivative of new penalized log likelihood function will be equal should be equal to 0. So here is the formula. The multiplicative iterative algorithm is acted with this formula. We know that the ratio of delta U1 over delta 2U could generate a negative iteration, whereas the multiplicative iterative iteration should generate a positive iteration, so it needs to be approached with the gradient algorithm as follows. The next is using line search to increase the theta with k plus a half iteration to be theta with k plus 1 iteration, like this. So the maximum multiplicative iterative iteration applies like this. The iteration will be stopped when the theta with k iteration minus theta with k plus 1 iteration is less than the epsilon, where the epsilon is theta rank minus 6, and we obtain the theta. After we get the estimation of beta and theta, we apply them on brain cancer. The data used is brain cancer patients who are using electrocapacitive cancer treatment at CTEC Lab Edward Technology Tangerang. Data brain cancer patient from 2012 until 2016. And the total data that we use is 172. Here is the research variable. There are sex, age, monitoring frequency, surgery treatment, chemotherapy treatment, radiotherapy treatment, using herbal treatment, and using other therapy treatment. Here is the data analysis step. First, we have to collect the data. Second, we have to estimating the survival curve. The third, we have to know the proportional hazard assumption. The fourth, we have to perform the Cox regression model using maximum penalized likelihood. The next is conducting parameter significance testing, both simultaneously and partially. And last, we have to interpreting the Cox regression model using maximum penalized likelihood. And here is the result and discussions. The descriptive of brain cancer patients is used by looking at the survival curve to determine the characteristic of the survival curve of brain cancer patients based on the factors that are true to affect the survival of brain cancer patients. Here is the Kaplan-Meier of all variables. It can be seen that the Kaplan-Meier curve dropped rapidly from day 0 until day 500. In that time range, the probability of patients to survive is about 10.0, 0.7. The following days decreased slowly until the day 2000. The survival curve tended to be constant with a probability of survival is 0.4. Here is the Kaplan-Meier curve of each variable. In sex variable, we know that the both line doesn't intersect, which conclude that the probability to survive for male brain cancer patients are greater than the female. From the radiotherapy treatment variable, we also know that both line doesn't intersect, which means that the brain cancer patients who do not do radiotherapy have greater probability to survive than those who do radiotherapy. This also applies to the survival curve based on monitoring frequency if we divide it into categories. This figure shows that the more often brain cancer patients take control of the lab Edward, they will have high probability to survive. From the log length test, we know that the sex, monitoring frequency, and radiotherapy treatment variables have value each less than a significant level 0.05, which means that the survival curve between each group is significantly different. Here is the Kaplan-Meier curve of each variable, which means we know that the group in each variable intersect each other, which means that there are no difference between group in each variable. From the log length test, we also know that the groups of age, surgery, treatment, chemotherapy treatment, using herbal treatment, using other therapy treatment variables are not significantly different. Here is the proportional hazard assumption test. We know that the p-value of all variable is more than the 0.05, so that we can conclude that all variables fulfill the proportional hazard assumption and Cox proportional hazard regression can be used in this data. We also know that the likelihood ratio is greater than chi-squared, which means that at least one variable has significant effect on the model. And we also know that the monitoring frequency and radiotherapy status are a significant variable because they have a p-value less than 0.05. From the significant parameter estimate of Cox maximum penalized likelihood, we know that the hazard ratio of monitoring frequency is 0.85, which means that the more often the brain cancer patient consult, he has a smaller risk of dying. We also know that the brain cancer patient who do radiotherapy have a risk of dying 2.58 times greater than those who do not do radiotherapy, whereas radiotherapy help to destroy tumor cells and prevent them from returning, which means radiotherapy can extend the survival time of brain cancer patients. This is because their confounding factor affect the result of the study. From the table 3, we get the model of Cox regression. Here is the Cox regression model, and where the H0 is a baseline hazard function estimation and the value can be changed from time to time. The estimate of baseline hazard function can be present graphically as follows. Here is the baseline hazard function estimate curve. The death rate of the brain cancer patients from day 0 until day 500 up and down quickly, but after day 500 until day 1500, the death rate up and down slowly, where the day after day 100 and 1500 or 5 years, the death rate of brain cancer patients is constant. And here is the conclusion. Based on the result above, it is known that the more often the brain cancer patients consult, he has a smaller risk of dying. In addition, it is also known that brain cancer patients who do radiotherapy have a risk of dying 2.58 times greater than those who don't do radiotherapy, whereas radiotherapy helps to destroy tumor cells and prevent them from returning, which means radiotherapy can extend to survival time of brain cancer patients. This is because their confounding factor affect the result of discussion. And the second, the death rate of brain cancer patients from day 0 until day 500 or 2 years up and down quickly, but after day 500 until day 1500 or 4 years, the death rate up and down slowly, where day after day 100 and 1500, the death rate of brain cancer patients is constant. Here is the reference. Okay, that's all my presentation. Thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.